Question number 14. The shape XYZ shown in the design for an herring. The straight lines XY and XZ are equal in length. The curve YZ is an arc of circle with center O and the radius 5 millimeters. The size of YOZ is 1.1 radians. XO is 15 millimeters. Find the size of XOZ. So we have to find this angle XOZ. This is basically identical on both sides. So complete circle is 2 pi. 2 pi minus 1.1 and divided by 2, we'll get one of the angles. Let me just get my hands on calculator. So 2 pi minus 1.1 by 2 is 2.59. 2.59 radians. B part says find the total parameter of the herring to nearest millimeter. So I need XY, YZ and ZX, all three sides. So starting with XY, I have this side which is 5, I have this side that is 15, and I have the inclusive angle, so I'm using cos rule. For XY square is equals to 5 square plus 15 square minus 2 into 5 into 15 into cos of 2.59. Make sure calculator is in radians mode. So 5 square plus 15 square minus 2 into 5 into 15 into cos of 2.59. That is 377. Square root of answer XY is equals to 19.4 and YZ is also equal to that. On the other end, for X, Y and XZ is 19.4 millimeters and YZ is S equals R theta. Radius is 5 and angle is 1.1, that is 5.5. So total perimeter is 19.4 times 2 plus 5.5. 19.4 times 2 plus 5.5 is 213.4, and to nearest millimeter, that is 213 millimeters. Area of sectors. Introduction of a new formula, that is area is equals to 1 by 2 r square theta, or area is equals to 1 by 2 r s, where s was the arc length. S equals r theta. So these are the three formulas in addition to the ones we used to do in O levels. And let's find some exam style questions. Okay, there's one. Question number 12. In the diagram, AD is equals to AD and BC are arcs of the circle. AD and BC are arcs of circle with center O such that OA equals OD equals small r, AB equals DC is equals to 8. So this is R, this is 8, and angle is theta radians. Given that the area of shaded region is 48 centimeters square, show that R is equals to this. So area of shaded region is basically larger sector minus smaller sector, and formula is area is equals to 1 by 2 r square theta. So for the larger one, I'm writing 1 by 2 and radius is basically r plus 8. R square and angle is theta minus area of smaller is 1 by 2 r square theta itself. And now we open the formula. This is theta by 2, that is a square, plus 2ab plus b square minus r square theta by 2. And now we multiply, this becomes r square theta by 2 plus 2 goes with 16, 8 r theta plus 32 theta, and this negative r square theta by 2 will go away with this positive one. So we are left with r 8r theta plus 32 theta, and on the other end it is given that the area is 48. So we can equate it with 48 and we have to make subject, that is r. So 48 minus 32 theta over 8 theta is equals to r. Now split them, 48 by 8 theta minus 32 theta by 8 theta. 8 1 times, 8 6 times, angle goes with angle, 8 1 times, 8 4 times. So we are left with 6 over theta minus 4 is equals to r shown. B part says given also that r is equals to 10 theta, calculate the perimeter of the shaded region. So for the perimeter we need 4 sides. This is 1, this is 2, 8 plus 8 is already there, 8 plus 8. Now AD S equals r theta. S equals r theta, where r is given that it is 10 theta. So 10 theta times theta is 10 theta square. And BC is again S is equals to r theta, which would be r plus 8, and angle is same, and r is already given, that is 10 theta plus 8 and theta. So that is 10 theta square plus 8 theta. Now we add these with them, that becomes 20 theta square plus 8 theta. So after getting this is one of the equation, and r equals 10 theta could be replaced here. 6 by theta minus 4 is equals to 10 theta. Only unknown is theta. So 6 minus 4 theta equals 10 theta squared. Rearrange 10 theta square plus 4 theta minus 6 is equals to 0. Divide the whole equation with 2. That is 5 theta square plus 2 theta minus 3 is equals to 0. So 5 3 times is 15. We adjust with 5 theta minus 3 theta minus 3 is equals to 0. Taking out common, 5 theta, that is theta plus 1, minus 3, that is theta plus 1 equals to 0. So 5 theta minus 3 equal to 0. Theta is equals to 3 by 5, and on the other side theta is equals to minus 1. This is rejected, which cannot be. So theta is 3 by 5. So we just plug it in here, which would be, let me change the color. 8 plus 8 is 16 plus 20 into theta, we got that 3 by 5. 3 by 5 squared plus 8 into 3 by 5, and use of calculator. So 16 plus 20 times 9 by 25 plus 8 into 3 by 5, and the answer is 28. Perimeter is 28 units per centimeter. Any confusion? Let me bring this out so we have more writing space. Question number 15. Quickly get this diagram here. So there's a straight line, and that's the radius on both sides. P, Q, this is R. O, radius is 10 centimeters, angle is 0.3 radians. This area is S. Now let's see. The diagram shows OPQ, sector of circle with center O, radius 10 centimeters. Angle POQ is 0.3 radians. The point R is on OQ such that the ratio OR ratio RQ is 1:3. So OR ratio RQ is 1:3. So we can actually find the length, because we have OP, OR, and let's say 1/4 of 10. So this is 0, 2.5. This is 2.5 centimeters and that is 7.5 centimeters. The region S shown shaded in the diagram is bounded by QR, RP and PR. So this is the bounded region. Find the perimeter of S, giving you answers to three significant figures. So for perimeter there are three sides, QP plus PR plus QR. So I already have QR, that is 7.5. For PR I'm going to use cos rule. So this is PR, that is unknown. Angle is 0.3. One of the side is 10, the other side is 2.5. So PR squared is equals to 2.5 square plus 10 square minus 2 into 2.5 into 10 into cos of 0.3, and PR is equals to 2.5 square plus 10 square minus 2 into 2.5 into 10 into cos of 0.3 is 58. Square root of 58 is 7.647. So 7.647. Now for QP, that is arc length. So QP is equals to R theta, where radius is 10 and theta is 0.3, leaves an answer of 3. Now we add them. 3 plus 7.647 plus 7.5, and it is 18.147, and degree of accuracy was specified in the question, which is three significant figures. So this makes it 18.1 centimeters. B part, the area of S, giving you answers to three significant figures. So area again. Area of S would be complete area of sector minus the area of triangle, which is PRO. So complete area is 1 by 2 R square theta minus 1 by 2 A B sine C. Use of calculator, 0.5 times 10 squared times 0.3 minus 0.5 times 10 times 2.5 times sine 0.3, and we're left with 11.3 centimeter square. Question 16. The diagram shows sector OAB of circle with center O, radius 12 centimeters. Radius is given, angle 1.2 that is given. The line AC is a tangent to the circle with center O. That means this angle is 90 degrees because of this tangent to the circle center O, and OBC is a straight line. OBC straight line. The region R is bounded by the arc AB and line AC and CB. Find the area of R correct to two significant figures, correct to two decimal places. Okay, area of R, and let's use this diagram only with the working space. What's that? Let me extend this space. So we are going to find the area of shaded region, which would be complete triangle minus sector. So for complete triangle, I need to find AC first, and I'm using tan. Tan of the given angle, which is 1.2, is equals to perpendicular AC over base, which is already given OA, that is 12. So AC is equals to 12 tan of 1.2. So I'm considering I have this side. So for area was it? Find the area of R, yes. So for area of R, this is now 1 by 2 into base length is 12 into height, which is 12 tan of 1.2 full triangle minus this sector right here. So minus this sector is 1 by 2 r square theta. What were these 8 marks for? That's done. 0.5 into 12 into 12 into tan of 1.2 minus 0.5 into 12 squared into 1.2 is 98.79, approximately equal to 98.8 centimeters square. This was area of R. Then B part says the line BD is parallel to AC. BD parallel to AC. Find the perimeter of DAB. Okay, if it is parallel, what we actually know is that this angle is again 90 degrees. And we have to find the perimeter of DAB. So in order to do that, we need 1, 2 and 3 sides. AB S equals R theta. AB is equals to R, that is 12, and theta, that is 1.2. 12 into 1.2 is 14.4. Done with the first side. Now BD. So now see, OA is 12, so OB is also 12 because that is radius. For BD, I'm using sine theta. So sine theta is equals to perpendicular BD over hypotenuse, that is 12. So sine of 1.2 times 12 is equals to BD. BD comes out to be 12 sine of 1.2, that is 11.18. Yes, OB is also the radius, that's why we take them equal. So now we have AB, the arc, we have BD, the straight parallel line, and I can find OD using Pythagoras theorem because I have 1, 2 sides. So OD is equals to square root hypotenuse square minus 11.18 squared and this comes out 11 square, 12 square minus 11.18 square, that is square root answer. .35. Sine theta was perpendicular over hypotenuse. 12 sine 1.2. Let me quickly check. Okay, so this is 4.35. So when we subtract this from 12 minus 4.35, we're left with 7.65. So perimeter is equals to 7.65 plus the arc AB, which was 14.4, plus BD, that is 11.18. 7.65 plus 14.4 plus 11.18, and this is 33.23 centimeters, approximately equal to 33.2 centimeters. 2 decimal places, so this is the answer. Question number 2 in next exercise. The diagram shows the triangle OCD with OC is equals to OD equals 17, that is radius, and CD is equals to 30. This is 30, diameter is 30, so radius should be 15 and 15. The midpoint of CD is M, a semicircle arc A1. with center M is drawn, so radius for this A1 is 15 and CD is diameter. A circular arc A2 with center O radius 17. This is A2 which has this radius 17 is drawn. The shaded region R is bounded by the arcs A1 and A2. Calculate, giving answers to two decimal places, the area of triangle OCD. So let me first find this angle, and there are two ways we can do this. Either we use cos rule, or I can just split them into two and use the 17 and 15 and find this angle and then double them. So I'm using sine theta is equals to perpendicular over hypotenuse, and theta is equals to sine inverse of 15 by 17. So shift sine 15 by 17, I got 1.08, and 1.08 times 2 is 2.16. This complete angle is 2.16. Having said that, area should be 1 by 2 A B sine C, which is 2.16. So 0.5 into 17 into 17 into sine of 2.16, that is 120.13. So 120.13. The area of shaded region, yes, is the area of shaded region R. Now in order to do that, if I may find area of this sector in white, that is 1 by 2 R square theta. So O, C, RK2, D and O, this is 0.5 times 17 times 17 times 2.16, and the area is 312.12. I already have the area of this triangle. When we subtract these two, I get area of this blue part, that is 312.12 minus 120.13, and I'm left with 191.99. This is the area of this blue section. Now this lower part, CMD diameter and A1, this is a semicircle pi R square by 2, this complete semicircle, and when I'm taking away this blue area, and I'll be left with the shaded area R. So pi R square by 2 minus 191.99, and I'm left with 161.44 rounded to two decimal places. Question number 3. The diagram shows the circle center O of radius 6 centimeters. Point A and B on the circumference of the circle. The area of the shaded major sector is 80 centimeters square. Given that AOB equals theta radians, where this is between 0 and pi. So basically this is theta, and area of this section is 80 centimeters square. Calculate the value of to 3 decimal places for theta. So on the other side, I can write 1 by 2 R square theta is equals to 80 for the other side, for the shaded side. So 1 by 2 R square, and theta for this section should be 2 pi minus this labeled theta, or let me say we use a different symbol. Let's say I'm using X. So that is 2 pi minus theta is equals to 80. Now we have to make theta the subject and solve for it. 6 square is 36. 36 by 2 is 18. So 2 pi minus theta is equals to 80 by 18. 2 pi, and bring this to left hand side and take theta on the other side. and we're left with 2 times pi minus 80 divided by 18, and theta is to 3 decimal places 1.839 rounded to 3 decimal places radians. B part is the length in centimeters to 2 decimal places of the minor arc AB. So that is S is equals to R theta, where radius is 6, and we just got the value of theta, that is 1.839. .034 centimeters. Next question. The diagram shows a sector OAB of circle center O and radius R. The length of the arc is AB, and that is P. AOB is theta. Find theta in terms of P and R. So that is S equals R theta. Find theta in terms of P and R. That would be P over R is equals to theta. First part. B part says deduce the area of the sector is 1 by 2 PR. So formula is 1 by 2 R square theta, where 1 by 2, or we can also use 1 by 2 RS. 1 by 2 where R is the radius and S is the arc length, which is given as P. So 1 by 2 PR. Second part, this is more generic question. Given that R is equals to 4.7, P is 5.3, where each has been measured to 1 decimal place, find, and giving your answer to 3 decimal places, the least possible value of area. So we already have this area, which is 1 by 2. Value of P is given 5.3 and least possible value, and it has been said that it has been measured to 1 decimal place. 1 decimal place would mean 0.1 with an accuracy of 0.05. Remember the topic of limits. So to find the least possible area, we are using the lesser values. So P is actually 5.25, and for R we are using 4.65. So 0.5, 5.25 times 4.65, or else we would have just copied the values and plug and play. 12.3 decimal places 206. This is C part. For D part, the range of possible values of theta. So S equals, we already had theta P over R. So theta is P by R. Now maximum value would be when we use the maximum value of P, which is 5.35, and least value of R 4.65. So this gives us the maximum value of theta. For least value, we use 5.25 lesser value of P and 4.75 greater value of R. So 5.35 divided by 4.65, and using it again to 3 decimal places, this is 1.151, and 5.25 by 4.75 is 1.105, and we can write 1.105 is less than equal to theta is less than equal to 1.151. That is least and greatest values of theta. Question number 5. The diagram shows, where did it go? The diagram shows the circle center O, radius 5. The length of the minor arc AB is 6.4. Calculate in radians the size of acute angle AOB. So straight away S equals R theta. This is 6.4, radius is 5, theta is unknown, so 6.4 by 5 is angle. 6.4 divided by 5, we get 1.28. So this is 1.28. radians. The area of the minor sector AOB is R1 and the area of shaded major sector is R2. Calculate the value of R1. So area is 1 by 2 R square theta. Area of R1 1 by 2 R square theta, that is 16 in this case. Calculate R1 ratio R2 in the form 1 ratio P and give the values of P correct to 3 significant figures. Okay, for R1 value is already there, but I'm just writing this 1 by 2 R square theta 1.28. On the other side, for R2 is 1 by 2 R is still same and theta multiplied with theta, which is 2 pi minus 1.28. And that is 5.003. So basically when we divide them both sides with half 5 square half 5 square, we get rid of this. So it is 1.28 ratio 5.003. Now I'm dividing it with the smaller value on both sides. So this is 1 ratio 3.9087 and up to 3 decimal places 9. 3 significant figures. So this is 1 ratio 3.91. Clear?